Uncertainty principle. In 1927, a German physicist, Werner Heisenberg, stated under the title On the Perceptual Content of Quantum Theoretical Kinematics and Mechanics that the more precisely the position of some particle is determined, the less precisely its momentum can be predicted from initial conditions, and vice versa. His inequality, which was later deprived by Hayes Kennard and Hermann Weyl, expresses the idea of uncertain principle mathematically. The product of the uncertainty of the momentum and the position is greater or equal than Planck's constant divided by 4 pi's. What does this inequality express? Furthermore, what does it even mean that the more precisely the position of some particle is determined, the less precisely its momentum can be predicted from initial conditions? First of all, particles. They're not just a bunch of much smaller ocean balls, but also much more smaller. And things get very funny in the micro world compared to the macro world we are currently perceiving. Contemporary physicists call it as in the quantum scale, in other words, in the smallest scale. In this case, we cannot actually see what is happening in the quantum world, but only through measurement from highly sensitive machines. The measurement makes no sense in the world we perceive, the wavelength. At the quantum scale, a particle is spread out over space so that there simply is not a precise location that it occupies, but a range of positions. Consider this. Imagine the measurement of a particle, a wave, as many soft closed hammocks connected to each other. Then, imagine the particle as one rock hitting one of them. Now, try to locate the rock. Obviously, we would shake the connected hammock and reason that the rock would be at the most intense of the connected hammocks. To know where exactly the rock is, more precise than just which bag, it would require an increasingly intense impact on the rock. Eventually, to be perfectly precise about the location, the connected hammocks collapse into one point and become the only point for us to locate the rock. Although not very accurate, this is roughly how the likelihood of a particle's location is determined in a wave. As we can see, to find the exact position of a particle, the wavelength must be collapsed into one single point. What does this have to do with the particle's momentum? When we arrive at the point where location is perfectly precise, the wavelength is also shortened to a single point, which in no way can be measured. According to de Broglie's equation, which calculates the momentum, wavelength is crucial for the calculation. Now that we have an undefined wavelength, it is impossible to calculate the momentum. On the other hand, if you want to have the most precise momentum, the solution only goes backward, and the precision of the position will then be exchanged for the precision of the momentum. From that, Werner Heisenberg concluded that in most cases, one cannot measure both a particle's momentum and position in perfect accuracy. In the inequality relation created by Heisenberg, we can see that the lowering of one's uncertainty would result in uprising of the other. How does uncertainty principle contribute to the world? Being one of the principles in quantum physics, the uncertainty principle contributes in hastening the field's progress. One of the significant discoveries in quantum physics, the quantum entanglement, has played an essential part in computer science. Using the qubits which applied to the understanding of quantum superposition, computer scientists can extend the computer storage by having it restore quantum scale messages that can represent things simultaneously. As much as the significant impact quantum physics has already made, the most well-known obstacle is the counterintuitive property of the quantum mechanics itself. Although it has already been applied to many other fields, quantum physicists admit that they have no idea why it will ever work. Practicing technologies that are unknown for its fundamental principles can be challenging and to an extent dangerous. Only the best wish for those intellectuals at the frontier. The end.